Today, many people believe that science and Christianity have always been at war. This idea is, pretty common in our culture. We often hear stories of faith holding back progress and reason fighting for freedom. The image is one of two opposing forces locked in a battle for the human mind. This narrative suggests that scientific advancement only happened when society began to shed its religious beliefs. It paints a picture where brave scientists had to struggle against the dogmatic authority of the church to uncover the truth about the natural world. This simple story, however, is not the full picture. It actually misses the deep and complex relationship that has existed between them for centuries. A closer look at history reveals a far more interesting and cooperative story. The idea of a constant war between faith and science is a relatively modern invention, one that became popular in the 19th century. Historians now often refer to this as the conflict thesis, and many have shown that it oversimplifies the past. Instead of being enemies, Christianity often provided the very foundation upon which modern science was built. It created an environment where the study of nature was seen as a valuable and noble pursuit. This support was not just a passive acceptance, but an active encouragement that shaped Western thought and institutions in profound ways, leading directly to the scientific revolution. This essay will explore this richer, more accurate history. We will see how Christian efforts to spread literacy made scientific knowledge accessible to more people than ever before. We will examine how core Christian beliefs about God and creation provided the philosophical motivation for scientific inquiry. The role of the Church in founding the first universities, creating centers of learning that nurtured generations of thinkers, will also be a key focus. By understanding this shared history, we can move beyond the simple myth of conflict and appreciate the powerful partnership that helped shape the world we live in today. It is a story not of opposition, but of collaboration and shared purpose. Understanding this connection is honestly vital. It changes how we see both science and faith. It shows us that the pursuit of knowledge about the natural world was not an act of rebellion against God, but was often seen as an act of worship. For many of history's greatest scientific minds, studying the universe was a way to better understand the mind of its creator. This perspective challenges us to reconsider the modern divide between the spiritual and the scientific. It invites us to see how a worldview that values reason, order, and discovery can be a powerful force for progress, illuminating both the heavens above and the world within. The ability to read and write is really the bedrock of scientific progress. Without widespread literacy, scientific ideas cannot be shared, debated, or built upon by future generations. Before the modern era, literacy was a rare skill, usually reserved for a small elite of scribes and nobles. Scientific knowledge, if it existed, was locked away and inaccessible to the vast majority of the population. This meant that discoveries were slow to spread and often lost to time. For science to truly flourish, it needed a way for knowledge to be recorded accurately and distributed widely. This required a society where reading and writing were not just for the few, but for the many. Christianity played a central role in spreading literacy across Europe and eventually the world. The Christian faith is based on a holy text, the Bible. From the earliest days, there was a strong impulse to have believers read the scriptures for themselves. This religious motivation drove an unprecedented educational effort. The mission to spread the gospel required translating the Bible into the common languages of the people, from Latin to German, English, and beyond. As these translations became available, it created a powerful incentive for ordinary people to learn to read. This mission was not about science, but it had a profound scientific consequence. The Protestant Reformation in the 16th century greatly accelerated this trend. Leaders like Martin Luther argued that every Christian had a duty to read the Bible. This belief led to a massive push for popular education. Schools were established and literacy rates began to climb steadily across Protestant countries. This created a larger pool of educated individuals who could participate in the intellectual life of their time. A farmer's son who learned to read his Bible could then go on to read a pamphlet about astronomy or a book on mathematics. The printing press, a new technology, amplified this effect, making books cheaper and more accessible than ever before. This explosion in literacy was a key ingredient for the scientific revolution that followed. Suddenly, a new scientific idea from someone like Copernicus or Galileo did not have to be slowly copied by hand and passed between a small circle of scholars. It could be printed and distributed to thousands of readers across the continent. This allowed for faster collaboration, more rigorous debate, and the rapid correction of errors. A wider literate public meant more potential scientists, more informed patrons, and a culture that was increasingly engaged with new ideas. The Christian drive for religious literacy had, perhaps unintentionally, prepared the ground for a scientific one. One of the most fundamental assumptions of science is that the universe is orderly and predictable. Scientists expect to find consistent patterns and laws in nature because that is what they have always found. This idea, however, is not self-evident. Many ancient cultures believed the world was a chaotic and unpredictable place, governed by the whims of capricious gods or random chance. In such a world, there would be little reason to search for universal, unchanging laws of nature. If a rock falls one day but floats the next based on a god's mood, a theory of gravity would be impossible. The belief in a rational, ordered cosmos was a necessary philosophical starting point for science. Christian theology provided exactly this worldview. At the heart of Christian belief is a single, all-powerful and rational creator. This God was not chaotic or arbitrary, but was a God of order who had designed the universe with purpose and intelligence. The Bible itself speaks of a creation that follows reliable patterns, such as the predictable cycles of day and night, the seasons, and the tides. This led Christian thinkers to believe that the universe operated according to a set of fixed laws that God had put in place. These were not just human inventions, but were real principles woven into the fabric of creation itself. This theological conviction gave early scientists the confidence to do their work. They believed that by studying nature, they were not just observing random events, but were uncovering the divine plan. The universe was seen as a book written by God, and the laws of nature were its grammar. Johannes Kepler, the astronomer who discovered the laws of planetary motion, was deeply motivated by this idea. He famously wrote that he was merely thinking God's thoughts after him. This perspective transformed the study of nature from a mere curiosity into a profound religious quest to understand the wisdom and majesty of the Creator. Furthermore, Christianity introduced a linear view of time, which stood in contrast to the cyclical views common in many ancient cultures. In a cyclical worldview, history endlessly repeats itself, and there is little sense of lasting progress. The Christian view, with a clear beginning in creation and an expected end, saw time as moving forward. This encouraged a belief in progress, including scientific progress. Each new discovery was not just another turn of the wheel, but was a step forward in humanity's understanding of God's world. This theological framework provided the essential philosophical soil in which the seeds of modern science could grow. Alongside the belief in an orderly universe, another key Christian idea was the view of human reason. Reason was not seen as a threat to faith, but as a gift from God. According to Christian theology, humanity was created in the image of God, and this was often interpreted to include the capacity for rational thought. This gave humans a special status and a unique ability to comprehend the world God had made. Therefore, using one's intellect to investigate the natural world was not an act of arrogance, but a fulfillment of a divine purpose. It was a way of using the tools God had given to appreciate the wonders of His creation more fully. This positive view of reason empowered early thinkers and scientists. They were encouraged to ask questions, to observe carefully, and to seek logical explanations for natural phenomena. This contrasted sharply with belief systems where nature was seen as sacred and untouchable, or where human inquiry into its secrets was considered forbidden. In the Christian framework, creation was good, but it was not God. It was a thing made to be explored, understood and even used for human benefit, a concept often referred to as the dominion mandate from the book of Genesis. This gave a kind of spiritual permission for scientific investigation and technological innovation. This mandate to understand creation is seen in early scientific practices. For example, the biblical story of Adam being tasked with naming all the animals was often cited by early naturalists as a model for the science of taxonomy. The act of classifying and organizing the living world was seen as continuing Adam's original God-given work. This gave a spiritual significance to the meticulous work of figures like Carl Linnaeus, the father of modern taxonomy, who was a devout Christian. He saw his classification system as a way to reveal the divine order present in the diversity of life on Earth. His work was both a scientific and a religious undertaking. Therefore, the drive to understand the world was not a secular impulse that arose in opposition to religion. It was deeply embedded within the religious worldview of the time. The gift of reason came with a responsibility to use it. To ignore the natural world or to fail to study it would be to ignore a primary revelation of God's power and wisdom. This theological conviction provided a powerful moral and intellectual incentive for scientific work. It told scholars that by opening the book of nature, they were learning more about its divine author, making science a worthy and pious calling. Ideas are important, but they need institutions to survive and flourish. You know, a key reason that modern science emerged in Christian Europe was the creation of a unique institution, the university. The university system as we know it today did not exist in the ancient world. It was, in fact, a new invention of the Middle Ages, and it was a direct product of the Church. The first universities grew out of the cathedral and monastic schools that had been the centers of learning in Europe for centuries. These schools were originally founded to train clergy in theology, law, and administration, but their curriculum soon expanded. The Church was not just the originator of the university, it was its primary sponsor and protector. Popes granted official charters to new universities, such as those in Paris, Bologna, Oxford, and Cambridge. These charters gave the universities a special legal status, protecting their independence from local kings and nobles. This autonomy was crucial as it allowed scholars the freedom to pursue their studies and debates without excessive political interference. The Church also provided significant financial support through land grants, tithes, and endowments, ensuring that these new institutions had the resources they needed to thrive and grow. By the year 1500, on the eve of the scientific revolution, there were over 30 universities spread across Europe. This network of institutions was unique in the world. It created a permanent, interconnected community of scholars who could share knowledge, debate ideas, and train the next generation of thinkers. The curriculum in these universities was broad. While theology was known as the Queen of the Sciences, students also studied the liberal arts, which included arithmetic, geometry, and astronomy. They studied the works of ancient Greek thinkers like Aristotle and Ptolemy, whose texts had been preserved and translated by Christian and Islamic scholars. This university system laid the essential groundwork for the scientific breakthroughs that were to come. It created a class of professional scholars, trained in logic and natural philosophy. It preserved and transmitted the knowledge of the ancient world, providing a foundation for new discoveries. Figures like Nicholas Copernicus were products of this system. He studied at several European universities before developing his revolutionary model of the solar system. The university was the crucible where the ideas, methods, and community that would launch modern science were forged, and it was an institution born from the heart of the Christian world. The story of the scientific revolution is often told as a story of secular heroes. However, a closer look at the lives of its key figures reveals that most of them were devout Christians. Their faith was not a private matter separate from their science. It was often the central motivation for their work. They were not trying to disprove religion. No, they were trying to understand the world that they believed God had created. For them, there was just no conflict between their faith and their scientific investigations. In fact, they saw their science as a form of worship, a way to glorify God by revealing the genius of his creation. Nicholas Copernicus, the Polish astronomer who proposed that the Earth revolves around the Sun, was a canon in the Catholic Church. His revolutionary book, On the Revolutions of the Heavenly Spheres, was dedicated to Pope Paul III. He saw his heliocentric model not as a challenge to faith, but as a more elegant and harmonious description of God's universe. Similarly, Johannes Kepler, who formulated the laws of planetary motion, was a deeply pious Lutheran. He believed that God had created the cosmos according to a perfect mathematical plan, and he saw his life's work as a quest to uncover that divine geometry. Perhaps the greatest scientist of all, Sir Isaac Newton, really exemplifies this connection. Newton is famous for his laws of motion and universal gravitation, which became the foundation of classical physics for centuries. Yet he spent more time writing about theology and biblical interpretation than he did about science and mathematics. He believed that the intricate and clockwork-like order of the solar system could not have arisen by chance. He wrote that its most beautiful system could only proceed from the counsel and dominion of an intelligent and powerful being. For Newton, the laws he discovered were proof of a divine designer. This pattern continues with countless other scientific pioneers. Robert Boyle, considered the father of modern chemistry, funded lectures to defend Christianity and wrote extensively on the harmony between science and faith. Michael Faraday, who discovered the principles of electromagnetism, was a member of a devout Christian sect and saw his scientific discoveries as revealing the unified work of God. These men were giants of science, and their work was driven by a deep conviction that in studying nature, they were tracing the handiwork of God. Their lives are a powerful testament to the synergy, not conflict, between Christian faith and scientific inquiry. No discussion of science and Christianity is complete without mentioning the trial of Galileo Galilei. This episode is often presented as the ultimate proof of the Church's hostility toward science. The story is famous. Galileo, armed with his telescope, championed the Copernican view that the Earth orbits the Sun, only to be condemned for heresy by the Catholic Inquisition in 1633. This event is the cornerstone of the conflict thesis, the idea that religion and science are fundamentally at odds. While the trial was undeniably a low point, viewing it as the defining moment of the relationship is a historical oversimplification. It was far more complex than a simple clash between faith and reason. The Galileo affair was driven as much by politics, personality clashes, and professional jealousy as it was by theology. Galileo had powerful friends and enemies within the Church. His abrasive style and his ridicule of his opponents, including the Pope who had once been his patron, created powerful personal animosities. The scientific community itself was not fully convinced of the Copernican model at the time, as the final proof had not yet been found. Furthermore, the Church was in the midst of the Counter-Reformation, a period of heightened sensitivity to challenges to its authority. Galileo's case became entangled in these larger political and personal battles. It is also crucial to recognize that the Church's objection was not to astronomy or the use of telescopes. In fact, Jesuit astronomers were among the leading scientists of the day and had confirmed Galileo's observations. The primary issue was Galileo's insistence on teaching the Copernican model as established fact, and his use of biblical interpretation to support his claims, which was seen as stepping into the domain of theologians. The condemnation, while a terrible mistake, was an exception, not the rule. For centuries before and after Galileo, the Church and its universities were the leading sponsors of astronomical research in Europe. The conflict thesis, which uses the Galileo affair as its prime evidence, is now largely discredited by historians of science. Scholars like David Lindberg and Ronald Numbers have shown that the idea of a long-standing war between science and religion was largely invented in the 19th century. It was popularized by books like John William Draper's History of the Conflict Between Religion and Science. These accounts were often biased and have been shown to contain historical inaccuracies. The true history is one of complex interaction, with far more periods of collaboration and support than of conflict. The Galileo case was a tragedy, but it was not the whole story. It is essential to acknowledge that Christian Europe was not the only civilization to make significant scientific contributions. To claim so would be historically inaccurate and culturally arrogant. The Islamic Golden Age, from the 8th to the 14th centuries, was a period of extraordinary scientific and mathematical discovery. Scholars in Baghdad, Cairo, and Cordoba made huge advances in medicine, optics, algebra, and astronomy. They preserved and translated ancient Greek texts that would later be rediscovered in Europe. Similarly, ancient China had a long and rich history of technological innovation, inventing paper, printing, gunpowder, and the compass long before the West. These contributions were foundational. Modern science stands on the shoulders of these earlier giants from different cultures. Islamic scholars like Ibn al-Haytham developed an early form of the scientific method, and their mathematical innovations were indispensable for later European astronomers. The transfer of this knowledge, along with the original Greek texts they had preserved, through places like Spain and Sicily, was a critical catalyst for the European Renaissance. Any honest history of science must recognize this global heritage and celebrate the achievements of these brilliant civilizations. Their work laid crucial groundwork for what was to come. However, while acknowledging these vital contributions, it is also historically important to ask why the scientific revolution, that sustained, explosive period of discovery from Copernicus to Newton, happened where and when it did in 17th century Europe. The answer appears to lie in the unique combination of factors that were present there. While other cultures had brilliant individual scientists and periods of discovery, Christian Europe developed a unique and enduring institutional framework for inquiry. The widespread network of universities, sponsored and protected by the Church, created a stable and competitive environment for scholarship that was unmatched anywhere else in the world. This institutional support, combined with the theological and philosophical motivations discussed earlier, a belief in a rational creator, an orderly universe, and the value of human reason, created a fertile ground for a new kind of science to take root and grow continuously. It was not a matter of superior intellect, but of a unique cultural and institutional matrix. The rise of literacy, driven by religious motives, and the development of the printing press further amplified this effect, allowing for the rapid and widespread dissemination of new ideas. It was this specific convergence of ideas, institutions, and technology that ultimately launched the scientific revolution on its world-changing path. Understanding the true, intertwined history of Christianity and science is more than just an academic exercise. It has profound implications for how we view the world today. The persistent myth of a perpetual war between faith and reason creates a false choice for many people. It suggests that one must either accept science and abandon faith, or cling to faith by rejecting the findings of science. This perceived conflict can cause unnecessary tension in our society, in our educational systems, and even within individuals who feel torn between their spiritual beliefs and their respect for scientific knowledge. This division impoverishes both sides of the conversation. By recovering the real history, we see that this is a false dilemma. We learn that a religious worldview not only can be compatible with science, but that it was, in fact, instrumental in creating it. The Christian faith provided the philosophical assumptions, the institutional support, and the cultural motivation that were essential for the birth of modern science. Knowing that pioneers like Kepler, Newton, and Faraday saw their science as an extension of their faith helps to dismantle the wall that is so often erected between these two ways of understanding reality. It shows us that a deep reverence for God can inspire a deep curiosity about His creation. This corrected history invites us to build bridges of dialogue and mutual respect. It allows for a more productive conversation between scientific and religious communities. When we recognize our shared heritage, we can better appreciate that science and faith ask different kinds of questions, but are not necessarily in conflict. Science is brilliant at answering questions about how the natural world works, the physical mechanisms and laws that govern the universe. Faith, on the other hand, addresses questions of why, questions of meaning, purpose, value, and morality. A healthy society needs both of these perspectives to flourish. Ultimately, this history should inspire us. It reveals that some of the greatest leaps forward in human knowledge were made by people who held a profound belief in a transcendent, rational, and good creator. Their faith did not hinder their science, it fueled it. It gave them the confidence to look for order in the cosmos and the motivation to dedicate their lives to that search. In our own time, so often marked by division, this story of partnership offers a powerful lesson. It reminds us that wonder, reason, and a search for truth can be unifying forces, allowing us to appreciate both the beauty of the universe and the deeper meanings it may hold.